We'll proceed in vector algebra and calculus. Vector algebra and calculus. Mind blowing. Okay, so discussion is going on that how we can calculate curve length. If I have a curve, if I have a curve, if I have a curve, then what is its length? What do you mean by curve? Curve means I have a sinusoidal curve. I have a sinusoidal curve. Then what is its length? I have a circular curve. I have a parabolic curve. If these are the curve I have, what is its length? That is under question mark. What is the curve length? Curve length, how I can find? Anyway, we have given lot of logic in calculating the curve length. Lot of logic that we have seen while calculating the curve length. Lot of logic we have given while calculating the curve length. Okay, the one logic what we gave calculating the curve length is get the vector. If I am trying to calculate, okay, so concept is I am trying to calculate curve length of this line. Up, 1 sec, 1 sec, 1 sec. This is xy axis. This is x axis. This is y axis. This is x axis. This is y axis. Now it is like that. Then there is a line like this. This is y axis. This is x axis. There is a line like this. What is length of this line? What is the equation of this line? Equation of this line is y plus x equal to 3. Here it is intercepting at 3 comma 0. Here it is intercepting at 0 comma 3. What is the length of this line? What we have seen till now is that if I have any curve, consider this curve is centered at the origin. Okay, this is the origin. This is x-axis and this is the origin. If it is centered at the origin, then this is the position vector at any point. If this position vector is xi plus yj, then if I calculate p equal to xi plus yj, this point is x comma y. This is called position vector. This position vector xi plus yj. If that is the case, then the derivative of this vector dp by dx, mind it, xi plus yj, y is dependent upon x. X and y are not independent to each other. I am not taking kind of xy plane and z plane where z is dependent upon x and y. Y is dependent upon x. This is very, very big thing. The algebra and difference between algebra and calculus algebra is calculus now it differentiates between independent and dependent. That's where algebra and calculus algebra is different. Algebra x into x is x square. Very, very important. In algebra, x into x is x square. Where is in algebra calculus x into x is x square by 2. That is the difference. One x is x-axis x and another x is y-axis x. If I say anyone what is x into x, then it is x square. What is x into x? Where the second x is y component function over x and that is x. One is x independent component, other x is function over x axis and that is fx y. X is x and y is function over x, that is x. What is x into x? X square by 2, not x square. That is algebraic calculus. Algebraic calculus talks about area contained in two lines, that is x and x. If it is x-axis, then function over x-axis, that is x, then it is like this. If I talk about simply two algebra, x into x, both are independent to each other, then it is x square. X into x, where first x is independent, second x is dependent upon first x, then it is x square by 2. Because independent x-axis is x, Dependent x-axis is like this. Okay, if that is the case, then area is area of the triangle from any point 0 to x. Then area is area of the triangle, that is x square by 2. Very, very big thing. Very, very big thing. X square by 2. So algebra and algebraic calculus are different. Algebraic calculus think about dependent and independent components. Okay, this is a crucial thing. Now, if I'm trying to find the length of the line, that is x plus y equal to 3, okay, we were talking here. So, if I have a position vector xi plus yj, then if I calculate the derivative of this, then it becomes I plus dy by dxj. We have seen that derivative derivative of any position vector is another vector. If one vector is xi plus yj, then dp by dx is I plus dy by dxj. That is another vector. That vector again has some direction. That direction is at any point x comma y, I plus dy by dx is tangential. Any point it is tangential. Okay, because dp by dx dot p is 0. So that is tangential. If that is tangential, then if I'm trying to find the length of this line, if I'm trying to find length of this line, the equation of line is y plus x equal to 0. Then if I take any position vector p, okay, so from here, if this is the line and we are talking about any point p here, then p here, then I take any position vector like this and calculate the derivative of this, then it will be tangential to the line, along the line. So if I calculate derivative of position vector, that becomes a vector equation of the line. So nice, right? This is the way we calculate the vector equation of a line. So x plus y equal to 3, then any point is xi plus yj. Derivative is I plus dy by dx j. Please watch previous video. So in that case, the I plus dy by dx j is along this line. That is the vector representation of this line. If that is the case, then it becomes I plus dy by dx is minus 1. Y plus x equal to 3, dy by dx is minus 1. So it is I minus j is the equation of, if this is x-axis, this is y-axis, and this is x plus y equal to 3, the vector equation of this line is I minus j. I minus j. What is the length of this line? What is the length of this line from here to here? I minus j. Okay, I minus j. What is its x component? 1. What is its x component? 1. What is its y component? Is minus 1. That's why it is like this. If it is x plus I, then it would have been 45 degree from x-axis. Now it is 135 degree from x-axis. That is xi plus yj, x minus I minus j. If if x-axis is 1, then what is the magnitude of this vector? 1 square plus 1 minus 1 square root of 2. If along x-axis its component is 1, then length of this vector is square root of 2. Now what we want? We want length of this line from 0 to 3 comma 0. When on x-axis it is length is 3, then what is the length of this vector? Then if it is 1, then it is square root of 2. When it is 3, then it is 3 square root of 2. This is kind of very coarse way of calculating. What is the length of this line? This line from 0 to x, then x into a square root of 2. X into the magnitude of the vector. Magnitude of vector into x. Hop, 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 hop. Magnitude of vector, whatever, there is a number, right? Into x. Magnitude of the vector into x, multiplication of two items, where one is constant, one is variable. If if both are not variable, then it signifies a rectangle. Multiplication of two items where both are not variable looks like these are two are sides of a rectangle, some hypothetical rectangle. If this is a rectangle, if this is a rectangle, if this is a rectangle, this if this is a rectangle, the rectangle one side is square root of 2 and another side is x. That why it is square root of 2 into x. How to find multiplication of two items? One side is a square root of 2, one other side is x. Finding the multiplication of two items is nothing but area of a rectangle whose one side is the square root of 2 and another side is x. If you calculate the area of this rectangle, how to calculate area? Take a square box whose size is 1 into 1. Just place it here from 0 to x again like this till the square root of 2. Now count it how many they are. That is the area of the rectangle. So if I have to multiply two items when both are not variable, then represent it as a side of a rectangle and try to find area of the it, and that is the multiplication. So square root of 2 into x is nothing but area of the shape it is making, rectangle. Now instead of a square root of 2, now in calculus the x along how much is the, this is the length of the vector we are trying to find, line from 3.0 to 0.3, where on x axis it is 0 to 3, length is 3. We calculated for x, any x. Okay, this proves that if I have multiplication square root of 2 into x, square root of 2 into x, then x is independent. It is along x axis. It is independent and square root of 2 is dependent. Okay. Anyway, in the square root of 2 we calculated because we calculated the magnitude of the vector, and vector had x component and y component. Indirectly, since it has y component, please be concentrate. Please concentrate here. So here something like if I'm trying to find the area of the line, first I get the vector representation of this line, that is I minus j. Make sure that the ith component is 1 so that we can calculate from 0 to x. So I minus j. Now yth component is 1, xth component is 1. So independent component is 1 and dependent component is minus 1. If I calculate magnitude of this array, this vector, then it comes at a square root of 2. Square root of 2 has y component also, which is dependent. Now if I say the net length is the square root of 2 into x, if if I minus j is a vector for which magnitude the length is the square root of 2, where x component is 1, what about if x component is 0 to 3, 3 into square root of 2? What about if x component is 0 to x, x into a square root of 2, or a square root of 2 into x, or a square root of 2 has y component? That's why it is dependent. So dependent into x, independent. Dependent into x, that is independent. What about dependent component has x also? In dependent component, that is square root 2, that is pure numeric. Consider it had x also. In that case, one thing in x and another is x, then it is not a rectangle. If I draw it, if the height is a pure numerical, pure number, and width is in x, then it is a rectangle. I can directly calculate its area by multiplying it. If it is not perpendicular, it is in some line or some curve. Instead of a square root of 2, what about it was a square root of 2 into x, or 1 plus x square root, whatever it is, 1 plus x square root, 1 plus x square root. That was the length of the vector. In that sense, it would have been some curve. Then area underneath it, we cannot calculate by multiplying x into a square root of 1 plus x square. If I want the area, because underneath area is equivalent to the multiplication, pseudo multiplication, abstract multiplication. If it is perpendicular to it, then area underneath it is exact multiplication of these two sides. But if it is not perpendicular, y is not perpendicular, it is in some curve fashion, then area underneath is not the multiplication of this curve and this curve. Like if the magnitude of the vector is a square root of 1 plus x square, then for any x, if like we had considered the array for the vector for which we are trying to calculate magnitude in I plus xj, then magnitude is 1 plus x square root. If that is the case, 1 plus x square root is the magnitude, then 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 I plus xj, the x component is 1. Now for on x-axis from 0 to x, the net length of the vector will be x into a square root of 1 plus x square, or 1 plus x square root into x. But this multiplication will not give the net whatever we want, because 1 plus x square root is the dependent component upon x. Its graph is not a straight line, it is some curve. If it is some curve, then we have to calculate this multiplication through calculation of the area only. There is a rare chance that when it is a rectangle, then area and multiplication are same. Two number multiplication and area of the rectangle with these two number as side of the rectangle are same. But if these two are, one is dependent and one is independent, independent will be x, but dependent is also in term of x, then their multiplication will not be normal multiplication. That multiplication we have to find through area only. When we are trying to find through area, then it becomes integral calculus. Okay, so if it was a square root of 1 plus x square, then we are trying to find for the x length x, then it becomes dx. Square root of 1 plus x square dx, not x, dx, dx. Okay, and x will be 0 to 3, limit will be 0 to 3. This is the way to calculate length of the vector. If the dependent component is pure numeric, then that into x will give the net length of the vector. No problem. The way we are calculating for the line, that is x plus y equal to 3. For vector notation is I minus j, its magnitude is square root of 2. For 0 to 3 multiplied by 3. Because I minus j, x component is 1. When x component is 3 multiplied by 3. 3 into square root of 2 is the length of this line from this cut, y-axis cut to x-axis cut. Now, now if this vector magnitude is not constant, it is algebraic. It is not constant, it is algebraic. Then we cannot multiply by x directly. We have to multiply by dx, because we are calculating the multiplication through calculation of the area underneath it. Multiplication of two items is exactly same as area underneath it if I draw the graph when it is rectangle. Otherwise, it is not same, and we go by the area, not by multiplication. This is independent and dependent. This is primitive calculus. This is algebraic calculus, and this is the real calculus. This is the real calculus. If that is the scenario, then what would be the kind of length? We tried it. So if I have a circle, if I have a circle, if I have a circle and we are trying to find the length of the curve of the circle, then what is the position vector? Xi plus yj. That is common everywhere. Xi plus yj. Xi plus yj is the position vector. If that is the case, then xi plus yj, if I calculate the vector that is tangential along the line, means along the line of this curve, what is the vector? Okay, if that is the case, then we have to differentiate it. dp by dx, then it becomes I plus dy by dxj. The next vector is coming, that vector is along the line, I plus dy by dxj. Now, if that is the vector, but that vector is variable, if I take a straight line and calculate the vector along the line, this at any point I take vector will be same. Like for this x plus y equal to 3 line, vector is I minus j. Any point if I take the vector, it is I minus j. Everywhere I minus j. But if it is a circle, anywhere if I take, then the vector is different. Can you see this here? The tangential vector is like this. Here 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 tangential vector is like this. Someone would say your position vector is changing and tangential vector will change. Like here position vector, if this is the origin, if this is the origin, then this is the position vector. Here position vector is like position vector is like position vector. When position vector is changing, then dp by dx, that is tangential vector, it will also change. Not true. If this is x-axis and this is y-axis, if this is x-axis, this is y-axis, This is the line that is x plus y equal to 3. If that is the case, then at this point on the line, this is position vector. Now this is position vector, this is position vector, this is position vector, this is position. Position vector is changing. Even though position vector is changing, dp by dx is not changing. That is I minus j. Position vector is xi plus yj, xi plus 3 minus xj. Position vector is changing, but dy by dp by dx, that is I minus j, is constant, because dp by dx, that is the whatever vector we are receiving, that vector, if this is x plus y equal to 3 line, that vector will be along tangential to the line. Since it is a line, everywhere tangent will be same. So that's why it is constant. But if I take here, though position vector are changing, if I calculate dp by dx, what will be dp by dx? I plus dy by dxj. That is I plus dy by dx j. Y equal to, equation of circle is x square plus y square equal to a square. Y equal to square root of a square minus x square. So I plus dy by dx, that is minus xy square root of a square minus x square j. This is the equation of the tangent to the position vector. That tangent equation, the tangent vector, is again a vector, and where it is variable. It is not constant. I minus xy square root of a square minus x square j. For this vector, the yth component, x component y, yth component is variable. This proves that at any x comma y, this vector would change. Here it will be like this, here it will be like this, here it will be like this, here it will be like this. Anyway, we will go with the fundamental. What the vector is along the curve? Along the curve, vector equation is I plus dy by dxj. I minus x by square root of a square minus x square j. What is magnitude of this vector? Magnitude of this vector is 1 plus x square by a square minus x square square root. A by square root of a square minus x square is the magnitude of this vector at any point x comma y. At any point x comma y, because this is variable. The magnitude is a by square root of a square minus x square. Can you see it is in x? It is not constant. So then what would be the length of the vector? What is the length of the curve? Length of the curve, what is the length of this vector when x component is 1? It was 1. I minus xy square root of a square minus x square j. Ith component is 1. So length is a by square root of a square minus x square. What would be length? Would be length when from 0 to x. This is origin. From 0 to any point x. Actually, I have to calculate 0 to a. But I am saying from 0 to any x. Then it is whatever the length for the vector 1 when x component is 1, a vector, that was dp by dx, p equal to xi plus yj. dp by dx is I plus dy by dxj. X component is 1, satisfied. Its magnitude is a by square root of a square minus x square. If x component is 1, then magnitude is a by square root of a square minus x square. If it is x, then it is x into a by square root of a square minus x square, or a by square root of a square minus x square into x. Now, what is dependent and what is independent? Into x, that is independent, because we are trying to calculate along x-axis from 0 to x distance. If it is one distance, then magnitude is a by square root of a square minus x square. If it is x distance, then it is square root a by square root of a square minus x square into x. This explanation you can search, it is not available anywhere else. Please do support us. So +91 is the India country code, 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code. Now, if the magnitude of the vector, that is I minus x by square root of a square minus x square j, where x component is 1, is a by square root of a square minus x square, then what is the magnitude of this curve, where vector is along the curve, right? This vector is along the curve at any point x comma y. This is the magnitude when the curve vector or tangential vector or curve vector, we can say curve vector x component is 1. When x component is x, then it is a by a square root of a square minus x square into x. What is independent here? The right side x is independent. What is dependent here? A by a square root of a square minus x square. The independent dependent component has x. We cannot multiply directly. Now it will. We have to get the multiplication through calculation of the area, where x-axis is this and y-axis of a curve is a by a square root of a square minus x square. If y-axis is a curve, y-axis is a curve. I don't know what curve it would be. It is some curve. Some curve with equation of the curve is a by a square root of a square minus x square, and x-axis is x. If I want to get multiplication of these two, then I have to calculate the area underneath it. That is the multiplication. If I go for the calculation of area, then it is integral calculus. What is your integral calculus? Now, instead of saying a by a square root of a square minus x square into x, now I have to replace x with dx, and their limit will come from 0 to x. 0 to x. Now, this is the exact multiplication. This is called primitive calculus, algebra calculus. Mind it, I have never used delta x tends to 0. Let's consider delta x distance, where delta x tends to 0, and then let's consider this. There's no consideration. Pure multiplication, but multiplication will happen through area. What about 1 is constant, 1 is not constant? Then I have to multiply it only, right? Not required. In this example, when we talked about the length of the line, the equation of the line is x plus y equal to 3 from 3 comma 0 to 0 comma 3, the vector is I minus j, where I, x component is 1, its magnitude is square root of 2. If magnitude of a square root of 2 is the magnitude of a square root of 2 is the magnitude of this line vector or curve vector. When x component is 1, when x component is x, what is the magnitude? Square root of 2 into x. That is the net magnitude. And this will lead to area. If I go with this multiplication directly calculating rather than drawing a graph where x-axis is x and y-axis is square root of 2, that will be constant. Then this forms a rectangle. So this is simple multiplication will also work because the shape is rectangle. But if it is not rectangle, then I have to calculate the integration. Then only we'll get the area. Now let's generalize it and calculate integration only everywhere. Forget multiplication in life at all. Then what it will become? It is square root of 2 into x. Let's go by integral calculus. The square root of 2 into dx, where in limit is 0 to x. Now let's generalize for everything. Now square root of 2 into dx, integration of dx is x. 0 to x, square root of 2 into x. But it is generalized, right? Now calculating the area of any shape, if I know that shape is rectangle, then it becomes a special case of this integral calculus. So calculating the area of any shape through normal multiplication is one special case of integral calculus. So integral calculus is more generic than normal multiplication. Don't go with normal multiplication at all. Go with integral calculus because that is a special case, that is normal multiplication. Anyway, multiplication you are getting if one is constant. Anyway, then what is the length of the circle? That is a by a square root of a square minus x square dx from 0 to x. Okay, if this is, every time I have to do this. Okay, what is the curve length? What is the curve length? Okay, the curve length is whatever the magnitude I get for the curve vector. When x component was 1, then its magnitude, if I am trying to calculate when x component was 1, the curve vector magnitude by a by square root of a square minus x square. What about if it is length? If x axis is from 0 to x, then 0 to x, a by a square root of a square minus x square dx. This is what we have seen. Okay, let's solve it. Then a by a square root of a square minus x square integration is sine inverse x by a. Someone can try. Then 0 to x, then sine inverse x by a. Then it becomes sine inverse x by a minus sine inverse 0. Sine inverse 0 is 0. theta is 0. Now it becomes sine inverse x by a. That is the length of the vector, this curve from 0 to x. If it is 0 to a, x is 0, 0 to a, this is the radius of the circle, then 1/4 length will get. Then sine inverse a by a, sine inverse 1 pi by 2, and a was outside, a pi by 2. A pi by 2 is the length of 1/4 of the circle multiplied by 4, 2 pi a. 2 pi is the length I thought of starting the modern way of calculus. This is primitive calculus. This is primitive calculus. What is modern way of calculus? So little bit I can do. Modern way of calculus is, now let's consider there is a position vector, there is a point called x comma y. There is a point here on the circle path is x comma y. Then position vector is xi plus yj. Now if there it is a circle and if there is any point x comma y, the position vector is xi plus yj, where the is x component is x and y component is y. That's why it is point is x comma y. If that is the case when x component is x, now what about y when x component is x plus delta x? Now this is x-axis and this is the point x. On top here point is x comma y. Let's move delta x here. The next point is x plus delta x comma new y. What is y? Function over x is y. Function over x is y. So first point is x comma fx. Another point is x plus delta x comma fx plus delta x. Okay, what is the line that is connecting these 2 points? One point is x comma fx. Another point is x plus delta x comma f function over x plus delta x. If I connect these 2 points, there are 2 points here, right? 2 points are here on the circumference. 1 point, 2 point, if I connect, then it will make a vector. What is the equation of this vector? The equation of this vector is this point x minus this point xi plus this point y minus this point yj. The equation of vector is x plus delta x minus xi plus fx plus delta x minus fxj. This is the equation of this vector. Then equation of this vector, then if I kind of settle it down, then it becomes the vector becomes delta xi plus fx plus delta x minus fxj. This proof is certainly not anywhere. Anyway, we'll proceed on this. So we are getting equation of a vector that found because we have 2 points on the curve, and 2 points are found because one point belongs to x and another point belongs to x plus delta x. If delta x tends to 0, then this line will be the line that is connecting 2 points here. It will be tangential if delta x is very small. Okay, but the equation will be again same, delta xi plus fx plus delta x minus fxj. That is the tangential vector equation, certainly. So the tangential vector that we were calling earlier dp by dx, here the tangential vector equation, position vector is xi plus yj at point x. Position vector is x plus delta x plus fx plus delta xj at point x plus delta x comma fx plus delta x. If I connect these two lines, it becomes a line vector that is delta xi plus fx plus delta x minus fxj. This proof is not available in previous proof was also not available anywhere else. So this vector is like that. If delta x tends to 0, we were trying to catch if this is the point that is x comma y and this is the point that is x plus delta x comma new y. If I connect these 2 points, this is the vector that is delta x plus fx plus delta x minus fx I j. Now, if this delta x is very small, then it tends to become tangential at that point. Then in that case, still the vector equation is delta xi plus fx plus delta x minus fxy j. Now, consider this as an assignment. The person has to think that how I am going to proceed now, calculating the length of the curve through this new approach, that is delta x tends to 0. This is called new calculus. So please do support us. We'll proceed on this. Please do support us. Plus 91 is the India country code. Plus 91 is the India country code. 9483160610. 9483160610 is the telephone number. Plus 91 is the India country code. Getting interesting, right? Step by step, it is getting interesting. It is not only matter of curve length, it is kind of cleaning the vector concept, algebra concept, calculus concept, then coordinate systems concept, everything. And this everything is useful in machine learning, artificial intelligence. We'll proceed on this.